For this example, we're going to find the volume of a solid, which is bounded above by a parabolic cylinder, z equals x squared, and the region below is enclosed by the parabola y equals 2 minus x squared, as well as the line y equals x. When we're doing these problems, the first thing we want to do is think about what our region looks like so we know how to set our integral up. Now, we have two functions in our region. We have this parabola opening down with a y-intercept of 2. So it's a parabola that looks roughly like this. Let's see, I could make that look a little nicer. So we have a nice little parabola like that, happy little parabola, it's not like Bob Ross. And then we've got y equals x, which is the identity. So that's a line which goes through the origin at a beautiful 45-degree angle. We have y equals x and y equals 2 minus x squared. Now, is this a situation when we look at our region here, this shaded region, do we want to set our bounds to be integrated with respect to x first or with respect to y? And so if you notice, if I think about left and right integrating with respect to x first, going from left to right here, as I move down through my region, you notice the left and the right bound change. So we do not want to integrate with respect to x first. It makes far more sense to integrate with respect to y, because here we have a very clear above function, which is this parabola in terms, or y in terms of x, and then a below, a bottom, which is the line. So if we were to set this volume up, my x values are going from this point of intersection on the left to the point of intersection on the right. If we calculated those points, we would get -2, as well as 1, 1. So my x goes from -2 to x equals +1. So then my above and below bounds in terms of y. On the bottom, we are bounded by y equals x. On the top, we are bounded by y equals 2 minus x squared. My function z, f of x, y, is x squared, and then we're going to list our bounds, dy, dx. So take a minute, pause, make sure you understand the setup, because the hard part is setting these up. We should be fairly comfortable with integration at this point. So from here, let's see, I've got v equals x equals, and that's a -2, so x is -2, 2x equals 1. And if I integrate this inner integral, integrating this x with respect to y, well, x is a constant, so this is just going to become x squared y. So we have x squared y, and of course we need to deal with our bounds, so we have y equals 2 minus x squared and y equals x. Of course, we're still going to integrate with respect to x after we simplify this expression. So I'm going to plug in 2 minus x for y. I'm going to plug in x for y. And we've got the integral from -2 to 1. I have x squared times 2 minus x squared minus x squared times x. We always simplify before we try to integrate, so that is 2x squared minus x to the 4th minus x cubed. And these are all each very easy for us to integrate using the power rule. So that becomes 2/3 x cubed minus 1/5 x to the 5th minus 1/4 x to the 4th. And we will plug in 1 and -2 You guys should be able to plug 1 into this, and you're going to get 2/3 minus 1/5 minus 1/4. Plugging in -2, we'll get -8, so -16/3, -32, so plus 32/5, and 16/4 or -4. And all of that busy work gives us 63/20. You guys can do the busy work and double check that for me. It should be right.